Yeah, good evening. So are you able to hear me?
Yes, sir.
Yeah. What about the problem? Means I think I asked you to complete for some 5 to 6 iterations. Did you work on that?
Yes, sir.
Sir,
So what solution did you get?
the relative error goes on decreasing, sir.
Yeah, error goes on decreasing indicates that you're converging towards solution. I mean, that's a positive sign. 1 second, please. 1 second. I'm connecting. 1 second. Yes, now I shifted to system. You can hear me. Please confirm me that whether or not you are hearing. Can you hear me well?
Yes, sir.
Yeah, okay, thank you. Okay, fine. Uh, okay, so I think we stopped here. So I think I asked you to perform some 6 iterations. So I hope everybody understood it. If anyone didn't understand, just ask me. So just confirm me that you understood this. If not, I can tell you this again. It's not a problem. I hope everyone did this. So what solution did you get finally here? What solution did you get?
Sir, we are reaching near zero, sir, but we are not able to
Get zero, sir.
Yeah, what did you get? 0.
No, sir, we're not getting a zero, sir. We're getting approximately to zero, sir.
That's okay. I'm not talking about error. I'm asking about the root value, the root of this.
Sir, it will be equals to numerical value, sir. True
Yeah,
solution equals to numerical value.
Yeah, of course. Okay. I'm asking you, what did you get at 6th iteration here?
1.32.
Sir, on
1.32, sir.
on 7th iteration, it is 0.66%, sir.
Okay. On 7th iteration, it is 0.66. Xn is 0.66. I'm asking this one, XNS, numerical solution.
1.33, 1.33, sir.
Iteration 1.32, sir.
Okay, 1.32. Okay, that means at 1.32, what is the error you get?
1.5%.
Okay.
1.31%.
Okay, anyways, 1.31, 1.5, that's okay. So I think further you have to go, okay? You just go up to say some 10 iterations, you may get maybe the good answer. Okay, this may change to some other answer. So that would be that means you would see like this. For example, if error is less than, say if error is less than some 0.01 percentage, then that is good. You can, at this error, whatever XNS you have at this error, you can take that, but that depends upon the problem. For example, if in the examination, if you ask like this, you perform the iterations until the specified error is less than or equal to 0.001 percentage. If this is the question to you, then you have to perform iterations until we satisfy this one. That means epsilon A must be like this or this one until we this, because this is our epsilon A, right? And this last column our epsilon A, until we get that we have to keep on do. Otherwise in the problems actually what they do is, see the examination for example for 2 marks they may ask like this, do for only 2 iterations, or sometimes they may say that in the 5 mark question do for only 4 iterations or 6 iterations or 3 iterations. So maximum limit in the examination, what they do, maximum you can go up to 5 iterations. That's what they do in the examination. So you need not really go after 5 iterations. So most of the questions you get max up to 5 iterations. But most
Sir,
probably, yeah.
Sir,
Ask me.
screen isn't shared, sir.
Oh, I'm sorry. I'm writing everything on air. Forget to share screen. Now, so maximum
Yes, sir.
5 iterations or 4 iterations. On an average, you will get most of the questions where you can solve with 4 and 5 iterations. That's it. So your questions will be based on that. So the question, the errors, they will specify something. So you have to test, you have to check this condition. If you meet with this condition, you can come out of iterations. Okay, then corresponding xns will be the answer for that problem. So likewise, you have to decide. Okay, so anyways, we will do further questions on bisection method. Means see, the thing is that we will do here one, but we can do many things in laboratory, because we will get opportunity to simulate things. End of the day, if you know algorithm, you can do anything. So we will go for next algorithm, false position method. There we will take one question, and that question we will use both bisection method as well as false position method, and then we will compare who is good with another question. Okay, we will take one more question and we will check who is good. But ultimately what we will come to the conclusion is that when you are bracketing the root, I mean any bracketing method, it's not only bisection method, when we are bracketing the root, the thing is that convergence is guaranteed, but the only problem is what here, it is slow. Bracket methods are really slow. That means you will have to take, for example, you see, in this case, even after 6th iteration, we didn't get the answer, okay? Proper answer. That means it's consuming more iterations. It's taking your time, it's killing your time. So therefore, we could say bracketing methods are slow, though they converge, but slow. That's anyways. We'll go for next one for now. Let's accept the next beautiful method, that is false position method. Yeah, 1 second. Let me take my pen. Let me change my nib. But one thing you have to remember, for example, if your curve is something like this, if your curve is tangential to this x-axis, something like this. Now in this case, as the curve is tangential to x-axis, okay, now we now using bisection method, I can't really get good answer. Okay, it's a flop. It's a flop in this case. So bisection method may not be the solution, may not be the appropriate method to find the root at this tangential point. Okay, so that point that problem you have, and then we'll go for next method. Next method is Regula, not regular, Regula Falsi method. Regula Falsi method, or I can say false position method, or I can say false position method. This is also bracketing method, or I can say linear interpolation method. Linear interpolation method. All right. So regula falsi method. In Latin, the meaning this is given in Latin terminology. In English terminology, you have false position method or linear interpolation method. So one of the bracketing methods is this. But for most of the functions, for example, you take one example, say you have some function f of x equal to 0, and you want to solve this function for the root value, for this x value, okay? Now, what I do, most of the functions, they are comfortable with false position method than with bisection method. The thing is that, of course, both methods are slow, yeah. But when compared to bisection method, false position method is somewhat good, in speed. All right. I mean, for most of the functions, but for some functions, for certain functions, to your surprising, BM will outperform FPM. That means BM is good when compared to FPM for certain other category functions. So we will see for what category of functions BM is good when compared to FPM. For what other category of functions FPM is good, so when compared to BM. So anyways, so it's good to take all those things. Okay. So anyways, your ultimate goal is what? Our ultimate goal is solving an equation. Okay, that's it. So anyways, you'll be taken some interval. So you'll be given some interval. So some interval, say a comma b. So closed bracket indicates what? Including a and b. Maybe sometimes the root becomes a or b. Okay, including a and b is the meaning of the closed bracket. Your ultimate goal is what? You will see that your function is continuous. Your function must be continuous. Where? Within the interval, right? Within the interval AB, you have to see to that your function, for example, like this. So this is my x-axis. I have some A here. I have some B. So I would say like this, for example, you have some function like this. Okay. Now within the interval AB, this function is continuous. Anyways, the function has to go this way. I think this way, okay? Because we are going to find real roots using these methods now. So the function must be continuous. If function is discontinuous, neither we can use BM nor FPM to find answer, okay? So everything is as usual. There is no difference. I mean that like f of a into f of b must be less than 0 within the closed interval. Then only there must be a root in between a and b. I mean that stuff is same. No difference in that stuff. So that will not change. All right. So for example, I'm taking some concave down function. Let me remove this. Okay. So this is Mr. x-axis, horizontal axis, that means domain. And I will take range values in the vertical, in the vertical axis. Now say you have some function like this. Which color I'll take? I'll take this color. Say for example, I drew some function this way, okay? So I have some function like this. Now where is the root here? This is my actual solution, yes or not? Where it is crossing your x-axis. So this is what your actual solution. Your ultimate goal is you need to find that numerically using false position method. So we will understand why the word false is there in this topic. How do we justify the word false? Okay. So now what I do, for example, I'll take something like this. This is my say. Now I'll take this is my A. This is my say what you call B. Okay. So I have A and B like this. Now, any one of you, please tell me, within the interval AB, is the function continuous?
Yes, sir.
Yeah, so the function is continuous, the function is smooth. continuous, there are no discontinuities. So happily we can apply false. So did we bracket the actual solution? Did we bracket the actual solution?
Yes, sir.
Yeah, so we bracketed or we closed the actual solution between A and B. So therefore, now it's time to apply our false position method, and we will see whether or not we're going to get things done. Oh, who is this fellow? I don't know. Accidentally I've installed that. So now same stuff. At A, what is this guy? This is f of A. And at B, you have something like f of B. Now, what is my goal? I will have to check this. If f of A multiplied by f of B less than 0, yeah, then only root is in between A and B. Then root is in between A and B. Yeah, so this fact we know. So sign change must be there, must be less than 0. Otherwise, there is no root between A and B. So f of A, this guy is negative, this guy is positive. So definitely it is less than 0, the product. Root is there between that. So with this conformity and with this confirmation, what I'll do now, I will try to take estimation. See, in bisection method, what is the estimation here?
A plus B.
A plus B by 2. That is what numerical estimation in every iteration for bisection method. Whereas in false position method, the estimation goes like this. The beauty, which color I can take? All colors are looking dull. Okay, I must take only light colors. So I'll draw a line like this. You see? Now what happened, at A, I found f of A. At B, I found f of B. Now draw a line, it's like a chord, okay? Or it's like a secant line. Draw a line which passes through f of B and f of A so that it must intersect, yeah, at x-axis. Now this one, what you're seeing here, this guy is your first estimation, xns1. Yeah, so where is your root? Your actual root is this guy. Your actual root is this. Now because of this, see, this is your false curve. Your actual curve is your orange curve, but this straight line, okay, this straight line intersected at the x-axis somewhere here, and now falsely we have this root. Yeah, this is the false position, right? Yes or not? The actual position is this one. This is the actual position, but by this means the false position is this. But anyways, this is my estimate. Though it is false position, yeah, I will try to win the game with the help of false positions only. Okay, this is my first estimation, and I will give the formula for that. How to find estimation formula, I'll just give you. It's very simple. How many triangles we are seeing here? I'm seeing triangle 1 and triangle 2.
Triangles.
Yes or not? Are
Yes.
these two triangles similar? They are similar, right? They are
Yes, sir, similar.
they don't have same size, but they are similar. Okay, so therefore I can just put simple Chotu mathematics and I can find out the equation for the estimate. I mean the numerical estimate. That's no big deal. I hope you are good at mathematics. So whether we are good or bad, it doesn't matter, but you have to understand the crux. So xns1 is this. Now what I do, I'll just come up with a formula later, but I will have to tell you this way. Now once we have this numerical estimation, now again you have to take, because I'll take green, because at A you found f of A, at B you found f of B. That's great. Now this is xns1. At xns1 you have to find f of xns1. Okay, so find f of xns1 here. Okay, say it is xns1. Now again what we will do here, xns1 is, I have some negative value in this case, whether it's negative or positive, forget about that. Now again, you take your scale. Okay. All right. So I will just draw one more secant line, or you can say chord. If you want to say chord, you can say chord. Otherwise, secant line. Yeah. See what happened now? Are we moving towards root now? Now, second time we are here now. Yes or not? Now, this guy is my second estimation, xns2. All right. Now again, what I'll do, I will take my function value here at xns2. I will find my function value fxns2. Now again, what I'll do the same stuff. So this becomes something happened. This guy is popping up. I can do some justice. Okay. Something approximate, just a second. So again, I'll take like this. Now with this approach, now this is my xns3. So this guy is my xns3. So this guy. So are we moving towards a solution now? Yes, right? See, these are false positions. False position 1, false position 2, false position 3. By means of false positions, we are moving to the actual solution. Yeah? So that's the beauty. So are you able to understand this?
Yes, sir.
Yeah. So
Yes, sir.
likewise also we can go. Now we have to construct a formula, an estimate, so that we can apply iterative stuff, iterative techniques, and we can find out the answer. So it's not a big deal. I think you can do this very well. You can use a similarity in the triangular stuff concept, and you can find out the answer. But end of the day, what you have to understand is that for every iteration, what we have decided here, for every iteration we have to decide what interval, yes or not. For every iteration, the interval is going to change. In bisection method, interval will decrease by half exactly. But in false position method, it's not exactly half, it's something else. But interval will change, right? So decide this. Every time you have to decide this one. You should not forget this. Okay. Do this. That means every time you will get new AB. Every time you get new AB. How do you come to know that? For example, you see, I have f of A first, okay, f of b second. I found its product, I got less than 0. So we just understood that there must be a root between A and B. Now, once we have that, we drew like a secant line passing through f of b and f of A. And now we have intersection at this point, and that we labeled as xns1. Now again, what I will do here, as you know very well, I must do this. If f of A into f of xns1. Do we require to do this one here?
We should do.
Yeah, obviously must do this. If f of A multiplied by this is less than 0, then what you say? Then there must be root. I mean, the root is in between.
A and XNS.
Very good. The root, see, this is between. I'm writing in short, between A and xns1. Otherwise where here? The root is
XNS1 B.
B and
between?
XNS.
And B.
Yeah, very good. Between xns1 and b. If it is in between xns1 and b, now we can happily confirm this. That is, this guy becomes new A. Yes or not? This guy becomes new A, and the new B in this case is same. If this is the case, if you have this is the case, now this is my A, my new A is again A. This one becomes B, right? So you know very well. So please do focus on this. For every iteration, you have to see to that. Well, I mean, you have some new interval. In new interval, one of the limits, whether A or B, may remain same, or both may change. But at least there must be change in one of the limits. Yes or not? So that you must take care of. So every time the iteration, I mean interval must and interval changes, the limits of the interval changes. Now you can just go for similarity in the triangular concept, or you can just use equation of a straight line, within the interval. For example, I'll take this one. For a given interval AB, for a given interval AB, can you understand my writing here?
Yes,
Sir,
sir.
it's clear. And
For a given interval A comma B, closed interval, that means including AB, the equation of a straight line, that connects the equation of straight line that connects point, what I can say, at B I have f of B, right, to another point. I'm writing everything for you so that you have a clear picture. So this stuff is given by anyone? Straight line equation, what is there? You have 2 points. You can do, right?
y minus y1
Y
is
minus
Okay, that's good. You just do that, you will get this answer. I'm writing the answer directly. Yeah, you can do that. So I'm writing it this way. So y is equal to f of b. I have this. I'm starting from right, and f of a, I have that, divided by b minus a, like slope you found, and then multiplied by x minus b plus f of b. Okay. Now the point xns, okay, I'm just taking, overall stuff. I'm taking this as A, this as B, this is like xns, okay. If I take this one as A1, B1, I will say xns, whatever, it's out. The convention is up to you. You can take any convention. The point xns, where this line intersects, where the line intersects the
y
x-axis,
equals to 0.
yeah, is determined by substituting y equal to 0. Very good. So just put y equal to 0, because at this stuff, y is 0. So there is no stuff for y. So now we solve the equation for this. Now what you get if you solve the equation for this? Just do it now. At y equal to 0, x becomes what? xns, right? At y equal to 0, x becomes, so 0 is fb minus fa divided by b minus a. Now this becomes what? Your xns, right? Yeah?
Yes, sir.
Yeah, because at y equal to 0, x is nothing but xns. That's it. So therefore, I'll put xns there, minus b plus f of b. You just find this. You must get like this. xns, it's very simple to remember also. There's no big deal in this. See, first write like this. How to remember this? You can do this, or don't require to remember anything, but you can do this. First write f of b, okay, minus f of a, okay. Now divided by, again, right, same thing, f of b minus f of a, okay. Now what you will do, you will have to multiply what here. So multiply f of b by a and this one by b. That's it. Yeah. So end of the day, you will have this xns. A f of b minus b f of a by f of b minus f of a. So first you can write f of b minus f of a by f of b minus f of a. Then in the numerator, just take a here and b here. That's it. Okay. So almost regular falsi method, bisection method, both will take almost same number of iterations, but for some functions, iterations will change. So So again, when should the iterations be stopped here? The iterations are stopped when? Anyways, you have some 4 measures, right? You have some 4 measures to estimate the root accurately. So out of 4 measures, which one did we take? Percentage, approximate, percentage, relative error. Yes or not? We took
Yes.
this approach,
Yes, sir.
approximate, relative, percentage error. So we will take this measure to find out XNS accurately. So until this satisfied, I mean until epsilon A is less than or equal to epsilon S. So this will be given to you. So until this satisfied, we can keep on iterate the stuff. Okay. Now, what you have to understand in this question is something interesting. You know what is that? Not interesting or interesting, I don't know. But see, frequently what is changing here? If you observe carefully, you are approaching to the root from one direction, not from both directions. Yes or not? You see, if you scrutinize this guy properly, you are fixing here. That means for this question, this part is fixed. Yes or not? That means this end B is fixed now. So you are fixed here. But what happening in this case is you are moving towards the root only from one end. Yes or not? You are approaching like this.
Yes, sir.
In this question, you are coming only from one end. But what about this end? This end, you are just fixed like that. Yeah, so now how to tackle down this problem? So this we will do in laboratory. This is interesting. So at that time, what we do, so we will take at B as we are fixed at B. So f of B, we will take it as f of B by 2. Wherever you have f of B, there we will take f of B by 2 for every iteration, and then we will solve. But I will just tell you how to do these things. Okay. But that means we can say that now the method is somewhat slow. Whenever you are at this situation, you can understand this way. I'm slow. How can we improve the speed? I mean, how can we improve the fastness here? How can we improve the fastness? What is your suggestion for this?
Sir, by assume the A value, sir. If
No. Okay, that's fine. Okay, okay, that's okay. But okay, of course, you're right. But I'm just talking in another way. As we are coming only from one direction, we are taking more time. Maybe right. If you try to come in both directions, then you may converge fast. Yes or not?
Yes, sir. That's
Yeah,
true.
yes,
so
sir.
we have to find some methods for that. We have to find, we have to find some ways for that, not methods, because regular falsi method is itself a method. So we have to find some mathematical ways, some ways we have to find. We have to construct something new so that we will try to attack the root from either ends, from A and from B. So that we will jolt down, in the next session. But for now, we have to compromise that we are just moving to the root from only one end, not from the other end. Other end is fixed here. Okay. So, uh, anyways, this guy is. I can't say anything here. This is a question mark now. I don't know. Yeah, I'm just dull. Okay. Neither I'm happy nor unhappy. So I'm somewhere in middle. So now we will solve uh, uh, one second. Yes, sir. It's a thank you. Okay. Okay, come down. So the same question. You please go home and solve this question, please. Which question here? Our previous question. Okay, you take this question. You solve this question using false position method. By the time you reach some few iterations, you will see that you are converging fast when compared to BM technique. Okay, but I will do this in one new example. I means you should know how to use FPM technique, right? So now you will appreciate bisection method, because in this example, BM is going to be, BM is going to outperform FPM. Outperform means BM is superior in this example, not always. So most of the times you can vote like this: 40% to BM, 60% to FPM. You can vote this way. For most of the functions, FPM is good, okay? But for this special function, you will find that BM is good, because we will compare the iterations now, okay? So the question is this: use bisection and false position methods to locate the root of Mr. f of x is x raised to the power of 10 minus 1. Okay, so he just say in the question you have like this: between x is equal to 0 and 1.3. Now you need not test really. Okay, so you have question this way. The question is this: what is the root here for this? Without any second thought, 1, right?
Yes, sir.
Yeah.
Yes, sir.
So he gave the interval also, interval extremes, left extreme and right extreme are 0 and 1 point respectively. So we will try to use both. Anyways, you know how to use bisection method. We will try to use false position first. Okay. Sorry. Take this way. So the tables are again as follows. I will take down the table this way: iteration, first field, this is Mr. A, and Mr. B I will take. Every time I don't show f of B here, table is getting big. Now I will take the estimation. So I'll take my estimation, XNS, and epsilon A in percentage. Okay, now life is very simple in this case. I don't show f of A, f of B. You find and put somewhere, but don't show it here on table. Table is getting bigger and bigger always, so we don't want that. Life is so happy now. I think from 8th, next Monday, gone, no scale, nothing. Okay, I have to use my weak skills in class to draw all the stuff. Okay, and I think we will enjoy. I think we will use this chalk piece boards. I don't know, we are going to very old. We are going to primitive stage, I think, again. We came from primitive era. Now we are in the modern era. But sometimes we will have to again travel back to primitive era, the chalk piece boards. Okay, iteration number 1. I want to use my false position method. What is my A first? My A is equal to 0, write down here, and my B is equal to 1.3. Okay, now XNS is what here? Use this guy. Use this formula, please. XNS. Now what you get? XNS. Just use him. Just use him. Whenever I want, I can scroll up. I can scroll down past the page and get something. But now I will have to weep. Now what is my A? My A is 0. So 0 into f of B. F of B is what here? F of B is what? You put B. What is my B? Yeah.
1.3 power 10 minus 1, sir.
Okay. So here I are. Indra bhai ide. 1.3 power 10 minus 1. Okay. Minus B. My B is 1.3. F of
Answer.
A. Yeah. What did you get?
Minus 1, sir.
Are you sure? Okay, I'll do 1.3 f of A is equal to 0. So 0 power 10 minus 1. by f of b. You must tell me f of b is what? F of b, you must tell me what did you get there. This you have to solve, minus f of a. F of a is, I'm just putting things here. This is my f of x, okay? So I'm just putting things here, writing, okay, 0 power 10 minus 1. So please use calci and just tell me what answer you get.
13.78.
You got 13.78.
0.094.
Very good. That's the correct answer. Just to solve it, you will get this 0.094. Okay, 3. Okay, something get like that. And what about epsilon a? Can I find this? No, I cannot write. Epsilon a formula is same. It will not change. What is this?
Yes, sir, you can't find.
XNS
100%, sir.
Yeah. Otherwise, we can
Present minus
percentage.
past.
Yeah, present minus previous by. What I'll take here?
Present, sir.
Yeah, you know what? You just go home and do also with past. Denominator also you take past, then you will almost get same iterations. Maybe 1 or 2 it differs. Otherwise, it will be same almost. Okay. So you will get this way. So in this case, it's full error 100% because I don't have any previous stuff. I have only this and this. I don't have this. So therefore, it is 100%. Okay. Iteration number 2. Now you tell me. Now what do you do? See,
Wait, f of b
because
less
yeah,
than 0.
f of a is equal to, I have negative value, I have -1. What did you get for f of 1.3? What value you obtained here? Someone who told me
12.78.
12.78.
Yes, sir.
Okay, so if I take this product, I will get less than 0. So therefore, there is a root between a and b. That's what we have. Now again, what I'll do? I'll do this. F of a multiplied by f of first one, xns. Okay, say this is first one, xns1. I will just take the product. F of a is equal to -1. What about this? What did you get? What did you get here? I mean, you have to find this. That is f of 0.
Minus 0.9999,
Okay, minus 0.
sir.
Okay, minus 0.99 and so on. So this is minus 0.9999 so on. Okay. So now if I take that part, then what happened now? Minus times minus positive. So the answer is greater than 0. So there is no root. That means, so therefore, no root in between a and xns1. Then where must be the root here? Where must be the root now?
1.3 and 0.09.
So root must be between xns s1 and b. Yes or not? So root must be between this, because it is, as it is greater than 0. Greater than 0, there is no root. So there is root here. So now he becomes what? A, new A, and he is Mr. B again. Okay. So now what is my A? A is xns1. Okay. xns1 is what? This guy. So now my A is 0.0943. Everybody, are we clear so far? Everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. So you have, because you should know that how we are changing every time the interval. Okay. Okay. So if you say we are clear, then I can go for next iteration. Everyone, are we clear so far? Everyone?
Yes, sir.
Yeah.
Sir,
Okay.
but in graph we are only changing A na, sir. We fixed
Here?
B na, sir.
Yeah.
In
Okay.
graphical representation.
What to do? But that's what I'm saying. See, in this example also B is fixed now. Okay.
Yes, sir.
In this example also B is fixed, because we have that category function. one of the functions we took such a way that in this case also b is fixed. Okay, so we can't do anything, just we have to accept and we have to we have to sail like that. That's it. Maybe for other functions we will see maybe something different, but in this case it's same. So b is 1.3. Now what are we going to get here? You must get something around 0.18176. Did you get like this? Just again use same formula, this one. Use
Yes, sir, the same 0.181.
yeah, 1817 you will get, and the error you will get 48.1. You will get this way, around this. You will get that, and again what you will do? Again same thing, yeah. F of a, the stuff you will do, you will take the part again. So if you do that, my a becomes 0 point, again you will get greater than 0, the part will be greater than 0. My b is 1.3. Okay, yes or not?
Yes, sir.
Yes, sir.
You must do like this. So 0 point you will get around 0.26287, and the error will be around 30.9%. You go to iteration number 4, again you take the product. Okay, if you take the product again, you will get like this, 0.26287, and this becomes 1.3. Okay, and you must get here around 0.33811, and if you find the error percentage, you must get something like this, so on, just go so on. In this example also, b will remain fixed, upper limit is fixed, that is b equal to 1.3 is fixed, a only changing. So we are approaching to the true solution, from one direction only, so on. Okay, so on you just do, so on you just do 6, 7, 8 like that. So until you find some error like this, epsilon a, until you find this 0.01%, you keep on do this. Okay, and that would be XNS. Are you getting this? Are you all getting this?
Yes, sir.
Yeah, but don't worry in the examination. Okay, at the time of written examination, you will never have a question whose iterations cross, say, some 6 or 7. Most of the questions they will give you such that the iterations will be almost like 4 or 5, almost 5, means maximum 5, not really more than that. Okay, so you'll be asking questions. You'll be asking questions. So okay, sir. What just now? So you will be asked questions like that. So don't worry about number of iterations. All right. The only thing is you have to understand the problem. If you are good at that, then rest of the things are okay. So shall we close now? I don't really want to take any extra time for you because by this time you are almost out. So I don't want to take your time. So shall we close? Do
Yes,
you have
sir.
any questions?
Yes, sir.
Okay, thank you.
Thank you, sir.